Morning students, I hope you all are doing good. It's me Sarehan Yusuf and today you are having your 6th lecture of physics. We started chapter number 3, that is kinematics of the linear motion. We discussed about the rest and motion. We also discussed about the different types of the motion. So let's continue chapter number 3. Let's start with the definition of the kinematics. Basically kinematics is a branch of the physics that is dealing with the motion of an object and the relationship between that motion and other physics concepts. Means kinematics is the branch that is dealing with the motion of the object without the reference to the force or agent that is causing the motion. Basically kinematics is derived from Greek word kinema, that means motion. Here I would like to discuss with you another branch of the physics that deals with the causes of the motion, that how the motion is produced, what are the factors which will affect the motion. This branch is known as the dynamics. So in kinematics we study about the position and motion of an object in space at a certain time without considering the causes of the motion, while in dynamics we study with the pushes pulls which cause or resist the motion. I would like to add the description of the scalar and vector quantities. As you all know that any quantity which can be measured by any of the method is known as a physical quantity. So the physical quantities are further divided into two groups, that is the scalar quantity and the vector quantity. If we are talking about the scalar quantities, so the physical quantities which are completely specified by their magnitude only are called the scalar quantities. For example, mass, time, distance, speed. It means that if we are having a quantity that we can easily describe by its magnitude only, means if we want to buy the vegetables, so we are just asking the greengrocer to give us 2 kilogram of potato or 5 kilogram of onions, means we are just telling the magnitude of something. So if we want to describe the time, if we want to tell the time, so how we are telling the time, we are just telling the time like this: it is 2 o'clock, it is 6 o'clock, means we are just using the magnitude for the description. So those quantities which only require the magnitude for its description is known as the scalar quantity, whereas the vector quantities, for the description of the vector quantities we require the magnitude and the direction both. It means that if we are talking about the distance, if we are talking about the force, if I am saying that I am giving or I am providing the force of 5 newtons, so you are just going to ask me where, in which direction. So I am going to tell you that I am providing the force of 5 newton towards the right hand side. It means that I am also telling you the direction, means those physical quantities which are completely specified by the magnitude and direction both are known as the vector quantities. Now here you can see that if you are talking about the displacement, so displacement is the shortest distance between the final position from the initial position. Here you can see that the final position is Q and the initial position is P. So the shortest distance from point P till point Q is basically the displacement. And displacement is a vector quantity because displacement is in a particular direction. Means for the description of the displacement we have to give the magnitude and the direction both. So displacement is a vector quantity and the direction of the displacement is from the initial position to the final position, whereas the distance is the length measured along the actual path taken. And for the description of the distance we don't require the direction, so distance is a scalar quantity. Now displacement versus the distance. The displacement of an object is not the same as the distance it travels. Example: throw a ball straight up and then catch it at the same point you released it. Means the distance is twice the height and the displacement is 0. Means distance and displacement are two different quantities. Now here I would like to add a point that the magnitude of displacement of an object is the same as the distance only if it travels in a straight line. Means if it is traveling in a straight line, so the magnitude of the displacement will be equal to the magnitude of the distance. Let's move to the average speed. The total distance traveled divided by the total time elapsed means the distance traveled upon the time taken. When we are going to take the ratio of it, so we'll get the speed. So average speed totally ignores any variation in the object's actual motion during the trip. And you should understand that speed is a scalar quantity, means we can completely specify the speed by magnitude only, and its unit is meter per second. Here comes the average velocity, means the rate of change of the position, means the rate of displacement is known as the average velocity. It is the ratio of the displacement to the time taken. Delta x means the change in the displacement, means from the final displacement you are going to subtract the initial displacement, means xf minus xi, and the delta t stands for the change in the time, means from the final time you are just going to subtract the initial time, means tf minus ti. And as you know that in the velocity the displacement is involved, so velocity is a vector quantity. We can conclude about the average velocity. Average velocity is a vector quantity. Its direction will be the same as the direction of the displacement, and SI unit of the velocity is meter per second. Class, today we discussed about the scalar and vector quantity, we discussed about the distance, we discussed about displacement, we discussed about the speed as well as the velocity. So I hope you all understand, and that's all for today. See you all in the next lecture. All of you stay safe, stay home. Thank you so much.